JSON Web Tokens, or JWTs, are an open standard used to share security information between two parties, a client and a server. Each JWT contains encoded JSON objects including a set of claims. JWTs are signed using a cryptographic algorithm to ensure that claims cannot be altered after the token has been issued. JWTs can be signed using a secret with the HMAC algorithm or a public-private key pair using RSA or ECDSA. If you're new to JWTs, don't worry if all this seems a bit confusing right now. We'll be diving into everything here in much more detail. In their compact form, JSON Web Tokens consist of three parts separated by dots, which are the header, payload, and signature. Therefore, a JWT typically looks like the following. Let's break down the different parts so everything makes a little more sense. The header typically consists of two parts: the type of the token, which is JWT, and the signing algorithm being used, such as HMAC, SHA-256, or RSA. The second part of the token is the payload, which contains the claims. Claims are statements about an entity, typically the user, and any additional data an application wanted to pass down with it. To create the third-party signature part, you have to take the encoded header, the encoded payload, a secret, and the algorithm specified in the header and digitally sign all of it. In authentication, when the user successfully logs in using their credentials, a JSON Web Token will be returned. Right now, our application just returns a Boolean. Whenever the user wants to access a protected route or resource, the user agent should send their JWT, typically in the authorization header using the bearer schema. The content of the header should look something like the following: authorization:bearer and then the token. If you're curious to learn even more about JWTs in general, make sure to check out the website jwt.io. Now that we understand the high level and specifics of JWTs, let's switch back to our IDE and see how we can start implementing them into our own application. Before we start, let's install two additional dependencies first that we'll be using in our project. These are nestjs/jwt and nestjs/config. Nestjs/jwt is a wrapper around the JSON Web Token package, which exposes methods for encoding and decoding JWTs. And nestjs/config, which was already introduced in the fundamentals course. We'll continue ahead here since we already have these packages installed, but if you're following along, just pause the video and come back when everything's finished. Once the installation process is complete, let's open up our app module TS file and head over to the imports array. Let's import the config module from the nestjs/config package and add it into our imports array here. Next, let's initialize the module by calling the forRoot method. With this in place, we can now create a local .env file where we'd store our private environment variables. This is where we'll store a secret that will be used for encoding and decoding our JWT tokens. Note that it's very important to never keep or push secret keys up to your repository. The Nest CLI already has .env files included in the gitignore file to ensure that this never happens. So, let's create our .env file in the root directory, and inside of it, let's add the following variables, which you can also find below the course video. JWT secret represents our secret key. It should be hard to guess and long, and usually the longer the better. JWT token audience identifies the recipients that the JWT is intended to be used for. Next, we have JWT token issuer, which identifies the principal that issued the JWT. And lastly, JWT access token TTL, which is the access token time to live, aka TTL. And we have this set to 3600 seconds, meaning every issued token will automatically expire after 1 hour. You can of course adjust this setting to whatever you think is best for your project, but we suggest keeping it low, meaning a short time to live. Note that environment variables we set here are essential to our applications starting up and running properly. Since our application depends on them, we need to make sure we have all of the required variables we need so we can connect to the correct databases, etc. It is a best practice to throw an exception during application startup if any required environment variables have not been provided or if they don't meet certain validation rules. To learn more, or if you need a refresher about environment variable validation in Nest.js, check out the schema validation lesson from the fundamentals course. Alright, so let's make sure to save this file and create a new directory inside of our IAM folder called config. Inside this folder, let's create a jwt.config.ts file. With this file in place, we can register a new configuration namespace under the JWT token. We've already covered config namespaces features in the fundamentals course, so check it out if you need a refresher, but essentially, we're just scoping or namespacing all of these configurations under the JWT namespace. Next up, let's open up the IAM module and add the JWT module to the imports array, making sure to import it from nestjs/jwt. Let's now call the register async method on it, and as an input argument, we can pass in the jwt-config.asProvider method, where jwt-config is our namespace configuration factory. If you haven't seen asProvider before, this method converts a factory to match the expected async module's configuration object, with imports, useFactory, etc. It's essentially just a time saver and prevents us from entering in unnecessary boilerplate code here. Let's not forget to also import the config module and register the JWT config factory so it can be injected by the authentication service. Great, we have no errors so far. Now, with the JWT stuff configured and loaded, we can navigate to our authentication service file and fill the gap we've left in our sign-in method. Let's start by injecting the JWT service, making sure to import it from the nestjs/jwt package. We have the ability to inject this service as we imported the JWT module into our IAM module. Now let's inject that JWT configuration we created using the inject decorator, giving us the ability to easily grab those JWT configuration key values here within our authentication service. With this in place, let's scroll down to the sign-in method implementation and replace that to-do comment we left with the following code. Here, we're calling the signAsync method of the JWT service to generate a new JWT access token. We're passing in the payload object as the first argument and the JWT configuration as the second one, which instructs the JWT service what the expiration time, issuer audience, etc. is. We'll worry about the payload object and decoding it later on when we create an authentication guard in future lessons. Back to our code here, you may have noticed in the first argument that we chose the property name of sub to hold our user ID value. It's a good practice to do this to remain consistent with JWT standards. We also decided to include the user's email address here in the signed token, but this is totally optional. We can pass down whatever we'd like in JWT tokens, but it's a best practice to keep them very lightweight and small, and only include things that are absolutely essential. For the second argument, we pass the JWT configuration object, passing down the audience, issuer, etc. from our namespace configuration, and we set the expires_in property equal to our access token TTL. Next, let's update the return statement so that instead of returning true, it sends an object containing the access token property. Great. With this in place, let's make sure to save our changes, head back to Insomnia, and test our sign-in endpoint again, making sure we pass in valid credentials in the request body. And as we can see on our screen, we received the access token back. Great. Our sign-in endpoint is now fully functional. Note, there are safer alternatives than sending the access token as a pure text, for example, by using the HTTP only and secure cookies option. Let's switch back to our IDE real quick so we can showcase this safer approach as well. Let's open up the authentication controller and let's focus on the sign-in method. Here, let's add a new parameter named response and annotate it with the res decorator, setting the pass-through property to true. Then, let's replace the body of this method with the following code that we can find below the course video. Let's also make sure to flag our method as async. Great, so let's save our changes, head over to Insomnia again, and call the sign-in endpoint once more. As we can see, the response body is now empty, and that's what we actually expected. But let's open up the Cookies tab and as we can see, there's our access token in here. Perfect. Just to make things easier to understand in this course, we'll be continuing on with the first approach, which was sending access tokens inside of the request body. But we just wanted to make sure you're aware of any potential risks there and provide you with an even safer cookie approach if that's something your application required. So let's make sure to switch back to our IDE and revert these changes we made in our authentication controller, save everything, and we'll be ready to continue forward in the rest of this course.